although I didn't say it, the answer we got in part B was correct. The velocity at the time the 5 kilogram mass hits the floor happens to be 4.43. So that's also true of the 3 kilogram mass. Now part C says, how much higher does the 3 kilogram object travel after the 5 kilogram object hits the floor? Well, I'm going to consider that the 3 kilogram mass is now at what I'm calling an initial reference level of h equals 0, because then hf will be how much higher it goes. Now, what do I know? It goes higher because it's going vertically upward until the velocity equals 0, and then it'll come back down. So I'm going to use energy concepts. In other words, the potential energy, the initial potential energy of the 3 kilogram mass, plus the initial kinetic energy will equal the final potential energy of the 3 kilogram mass plus the final kinetic energy of the 3 kilogram mass. Well, the initial potential, because I was smart and I chose my reference level to be h equals 0 at that initial point, is 0. And I also know at the peak height, the final kinetic energy is 0. So what I have here is 1/2 mv initial squared equals m times g times h final. Now what's interesting about this is my mass cancels. So what I have here is 1/2, and my v initial was 4.43. I have to square that. That's going to be equal to 9.81 times the final height. So now it's time to pick up our calculator. I do 0.5 times 4.43 squared. I divide by 9.81, and that gives us a final height from where it was when the 5 kilogram object hits the floor. It apparently goes up another 1 meter. Now you could do this using kinematics. It'd be like the kangaroo problem on the last test, but it's sure easier using conservation of energy.